Hey everyone, my name is Advait, and today I'm going to show you a cool new package called Checklist. Checklist came out in the ACL 2020 paper, and it's a great method to check how your machine learning model is doing on production. The benefit of using Checklist is that usually when you say, let's say you have a model that's like 95% accurate, right? You don't really know what 95% means. Is this good enough to deploy in production? Are there certain scenarios where I should be careful about the model? A single number doesn't give you enough knowledge about the model. Checklist solves this beautifully by creating a large number of test cases for your model. And thereby, you're able to see, hey, is my model doing well across, say, all genders, or is it biased on a certain population? Does my model behave unpredictably if I give it a certain kind of input? These are all questions that Checklist helps you answer. And yeah, without further ado, let's just dive right into it. The rest of this video is split into three sections. First, I'll introduce Checklist to the unfamiliar. Second, we'll do a quick demo of what Checklist can do for you in a movie recommendation scenario. And lastly, we'll also discuss the strengths and limitations of using a package like Checklist. So if you're already familiar with the package and just want to see the demo, feel free to skip ahead to that. Right, so what is Checklist? So essentially, Checklist is a way to create test cases like the software engineering test cases for your machine learning model. Each test case that you create with Checklist has two characteristics. The first is it has something that's called a capability. In today's demo, I'll show you a negation capability, and that will help you understand what that means. And the second characteristic of any test is the kind of test that it is. So in the paper, they define three kinds of tests: minimum functional tests, invariance tests, and directional tests. I'll go over the first two in the demo, and we won't cover directional tests today, but it's more along the same lines of the first two. Without any further ado, let's look into the test cases that Checklist creates. So this code is all posted in the description below if anyone's interested in checking it out. It's also very similar to tutorials put out by the official Checklist team out there, so feel free to check out those as well, also linked in the description below. So the first thing we do is go ahead and install and import the Checklist package. We'll be using editor and perturb. Editor is useful for minimum functional tests, which we also import, whereas the perturb is useful for the invariant tests. If this seems like a lot of jargon to you right now, don't worry about it. We'll discuss what these all mean as we go through the demo. So the first thing you want to do is create an instance of the editor class. What editor does is it allows you to create a template for your test cases. So for example, one template that we're using today is this is not mask thing. So this is a negation template. What does this mean? So an example of this would be, this is not a good movie in our movie recommendation scenario. So this thing over here is simply a list that we've defined. So I picked in 4 different kinds of things you might see in a movie review, right? The reason we're looking at movie reviews is, so an important factor if, say, you're building a recommendation system is to look at the movie reviews that a movie has and look at how many, say, positive reviews it has and how many negative reviews. So these kind of positive and negative reviews are generally done using a sentiment analysis model that takes in the review as an input and gives you a positive or negative label as an output. So today we'll be looking at, in this demo, we'll be looking at how we can analyze the performance of such a sentiment analysis model. Right. So let's say we have a review which is like, say, this is not a good plot or a good movie or a good show or a good storyline. So we just define like a set of things that we want to generate reviews like. And we can also say, so like just how like we've defined plot, movie, show, and storyline here, we can also define adjectives like good or bad and so on. However, we don't want to go through the manual effort of coming up with another list like this. And so what Checklist allows you to do is provide a mask and ask the editor to suggest what should go into that mask. Behind the scenes, this is using a Roberta model to create recommendations, and it will give you an output like, say, this, saying, hey, this is not an original movie, or this is not an interesting movie. And you can just use these recommendations instead of having to think about them on your own. What we do next is that we take a subset of these recommendations and we make them as positive and negative. So a bunch of, say, positive adjectives that could go in here would maybe be original, interesting, entertaining, so on, so on. And a bunch of negative ones could be, say, bad, terrible, or awful movies. So we've gone ahead and picked out some of the suggestions that's given to us by the editor. And the next thing we'll do is create a template with these. So again, it's just the same thing. This is not a positive movie, where this pause is now filled in with adjectives that we've defined, and the thing remains still the first set of movies or shows that we've defined. That's all the parameters that you need to pass to template. You also need to tell it what it should expect as a model output. So since you're saying this is not a good movie, we expect that the model should give a label of 0, which means a negative sentiment. Similarly, we also create a second kind of template, which is this is not a negative thing. So like this is not a bad movie. And here we say, hey, the model should give you a positive label or a label of 1. Once you specify these things, all we need to do is create this into a minimum functional test. And therefore, we just declare the test as an MFT with our editor templates. That's all there is to it. The next thing we do is, so we're loading in a sentiment analysis model for testing here. I'm just using a simple one from the pattern library. But honestly, you could just swap this out with any model and run the same set of tests for it. The first thing we do is define some predict probabilities function for the model. All this is doing is giving back the probability that a review is either positive or negative. That's all this is. The reason we want to define this as a function is because your test cases will expect a prediction function while running the tests. In order to pass that in, all we have to do is use a wrapper that checklist creates for us. And so we just declare an instance of this predictor wrapper with our function. And then we go ahead and do test.run with our wrapper that we created. You can also specify the number of examples you want the test case to run on. I think the default here is 200. And once it's done, you can just do test.summary, and you'll be able to see how many test cases did your model pass and how many did it not. So for example, this seems to be a pretty bad model because it has a 60% failure rate. And you can see some of the failures over here, right? So this is not an exciting movie. That sounds like a negative review. And therefore, you'd expect probability to be less than 0.5, but instead your model gave it a 0.7. The second one here, this is not a sleep-inducing show. So this does sound like a fairly neutral review, not really positive or negative. So maybe the 0.5 that's given back by a model is fine, and therefore the test is not really appropriate. But for example, the last one here, this is not an excellent show. This should definitely not give a positive probability of 1, and therefore this is another place that your model is doing badly in. You can also look at these results using visual summary if you're using an IPython notebook. And the benefit here is that you can freely filter in and look at all the places where your model is predicting incorrectly. Right, and that's all there is to it. We'll also look at invariance tests. So let's say I had a movie review that said, Johnny Depp was a great actor in this movie. Now that sounds like a positive review. And instead, if you had read another review that said, Robert Downey Jr. is a great actor in this movie, that's still a positive review, right? Like changing the name of the actor doesn't change whether the review is positive or not. And therefore, that's what an invariance test is. It's looking to see if your model is invariant to neutral perturbations of your input. So again, we'll just look at how this is done with a small data set. So let's say these were like a bunch of reviews that you had, like say Mary Keane was brilliant in the movie. Now the perturb class that checklist provides has a bunch of great default functions and perturbations. So for example, it has a perturbation called change names, which basically just looks for names in your input data and swaps them out with other names. And if, for example, you can see like this first, our first review over here says this was a very nice movie directed by John Smith. And when you do the perturbations, it changes it John Smith to say Michael James or Christopher Ward and so on. And you expect that your model is invariant to this kind of change. So similarly, you just go ahead and directly run the test. and you look at the summary of the results. And in fact, you see that, hey, your model fails 0% of the time. So it actually is invariant to changes in name, which is good. You can do other kinds of perturbations as well. Another popular one that is offered by default is add typos. So for example, you can see that when it adds typos, it shifts the position of the full stop in this review. Similarly, you can go ahead and run these test cases again and look at a summary, and you see that, oh, in fact, your model is sensitive to typos, and 28% of the time it doesn't. The probability changes significantly on a typo. So for example, the word brilliant is just slightly misspelled over here, and you can see that the model's confidence has gone from 0.9, really positive, to 0.5, which is a neutral review. And this is something that now you know that this is an actionable step that you can take to improve your model and the system. So yeah, that's about it with checklist. The strengths of using something like checklist, as mentioned by the authors of the paper as well, is that it helps you catch a much larger number of bugs and issues with your model. So for example, they say that NLP practitioners with checklist created twice as many tests and found 3 times as many bugs as users without it. However, checklist does have its limitations as well. A major limitation is that because you're using these templates, like for example, this is not a positive thing. These templates are really, really simple, right? And they may not be representative of what your reviews or what a movie review in production might look like. So in fact, for example, we pulled out a few IMDb reviews from the IMDb review dataset. And here's what an actual movie review might look like. For example, Cinderella is a beautiful film with beautiful songs, of course. And you can see that the review is really long, and it's nowhere near as simple as this is a good movie or this is not a good movie. And therefore, that's a serious limitation of checklists in the sense that the test cases often tend to be simplistic, and you need to ensure that you know that you pick the right scenarios and the right templates in order to ensure that this is useful for you. Thank you so much.